All right, let's start our chapter on square roots. Is mainly what I call the chapter. We deal with other roots besides just square roots. They could be cube roots, fourth roots, but a lot of the chapter deals with square roots. So let's start with those. We're going to talk about the definition of a square root. A square root is a number that if you take two numbers and multiply them times themselves, you're going to get that last number. It's a lot easier to show than it is to say in the definition. For example, 36 is a perfect square because it is 6 squared. So the square root of 36 would be equal to 6 because 6 squared equals 36. So what we're doing when we're finding a square root is we're finding a number times itself that would equal the number underneath this little square root symbol. If you have 0, the square root of 0 is always 0. And let's remember, if you get a number and you square it, you could have a 6 squared and that would give me 36, but also a negative 6 squared would give me 36. So sometimes we have to think about both the positive and the negative. So in these first ones, if we identify just the square roots, okay, of real numbers, for 25, 5 times 5 is 25, but negative 5 times negative 5 would also be 25. Then for 16, 4 times 4 would be 16, and negative 4 times negative 4. 49 is 7 times 7, or negative 7 times negative 7. Now let's look at negative 4. Is there any number multiplied by itself that would equal 4? Well, 2's give me a 4, but 2 times 2 gives me a positive 4, not a negative 4. Negative 2 times negative 2 also gives me positive 4. The only way to get a negative number would be to multiply a plus times a negative, and that's not the definition of a square root. You have to multiply the same sign to get the number for a square root. So for negatives, there are no square roots, so there's none for that negative 4. Now, a lot of the beginning of this chapter, it'll talk about just the positive square root. That's also called the principal square root. So if you see the principal square root only list the positive square root of the number underneath. The only time you'll get a negative is if you have a negative in front of that square root. So let's remember that. And then remember always square root of 0 equals 0. So let's look at some of these down here. The square root of 25 would be equal to 5. We're not going to put positive and negative 5 because it just really asks for the principal square root. For 0.81, that's going to be 0.09. Now, as a side note, you can use your calculators for these. You just need to be sure you know which button to use on your calculator to find the particular root you're looking for. On the calculator, you'll look for, there should be a square root button. A lot of times it is above the x squared button. You'll see it like in a different color. So on a lot of calculators, you have to hit the second button and then the little x squared to get the square root under there. If you have questions about your calculator, you are always welcome to come into the lab and ask questions, and we can show you how to use that calculator. Now on these, we're going to get a negative if we have a negative in front. So the square root of 36, well, 6 times 6 is 36, but I have a negative in front. That's going to carry to my answer, so I'm going to get a negative 6 for that one. The next one is a fraction. What you need to do is you need to take the square root of the top and then the square root of the bottom. So the square root of 4 would be 2. That's going to stay on top of a fraction. The 25 is underneath, so the square root of 25 is 5. So that would equal 2/5. You don't want to give me a decimal answer for that. You want to give the fraction answer for that. So don't use your calculator and give a decimal answer for that one. I need the fraction. On E, I know I'm going to have a negative carry over because I have a negative out front. The square root of 1 is always 1. 1 is a perfect square, it's a perfect cube, it's a perfect fourth. So anytime you have a root of 1, you're going to get 1 to come out. And then the square root of 9 would be 3, so that's going to be a 3 on the bottom. Now look at F, square root of -4. Remember up at the top we said that if you have a negative, you cannot really take the square root of it because two numbers times themselves can't equal a negative. You have to have positive, positive, or negative, negative. So for our purposes, right now, until we get to the end of this chapter and we talk about how to deal with negatives underneath, this is not a real number. Sometimes you'll see me write NARN for short, not a real number. All right, the square root of 1 is going to be 1, and the square root of 0 is just 0. All right, so far so good. Now a little bit more definition. When we talk about a root, I'm going to write this a little bit bigger so I can mark it up. When we talk about a root, we have a number that's underneath. That's called the radicand. You don't hear me use these words a lot. And then the number that is in the, I call it the pocket, but it's in the little check part of the root, is called the index. You'll hear me call that the number in the pocket sometimes. When you have a square root, just like that, there's an imaginary 2 in that pocket. That's going to come into play when we do some simplifying later on. Other than just a square root, you'll have cube roots, you could have fourth roots, and so on. And the numbers would actually be written as little numbers in the little check part. But on a square root, it's imaginary. It's given that there's an automatic 2 there. All right, so let's look at the next page. Now, this is a good little chart to have. I'm going to post in Blackboard a longer chart that gives perfect squares, perfect cubes, and perfect fourths. I think it's even got perfect fifths on there. That would be a good worksheet to print out to have in front of you when you're simplifying these square roots and cube roots and any of these roots. It's good to have a list in front of you. We can make the list ourselves, but I'm going to post that list, and it's going to have a list of perfect squares, perfect cubes, perfect fourths, and perfect fifths that a student did for me one semester. So again, you can use your calculator on a lot of these, and that's perfectly fine with me. But when we get into the section later on where we're having to simplify, not all of these can be done on the calculator because sometimes you'll get a decimal. But in the beginning, you know, a lot of these come out even. Now, let's talk about when we did square roots of negatives versus cube roots of negatives. Remember when we square a number, -4 squared, we always get a positive answer because a negative times a negative is a positive. So if you remember the rule from exponents that you may have done a long time ago, even exponents give us positive answers when we are raising them to powers. Odd exponents can give us a negative answer because if I took that same -4 and I cubed it, that's -4 times -4 times -4, which would be -64. So we can reverse that. We can take the cube root, and I'm going to use this first example that's over here. We can take the cube root of -64 because 3 numbers can be negative and get a negative underneath. That would just be a -4 for an answer. I'll put it over here because -4 times -4 equals -64. It's okay to take an odd root of a negative. If that number were to be even, then that's not a real number. You can't do even roots when you have a negative underneath. You can do odd ones though. So the cube root of -64 would be -4. If you're doing these in the calculator, I would put the number that's underneath the root in parentheses. That might also help. Just be very careful when you're using the calculator. All right, the fourth root of 256, so I need a number times itself 4 times is 256. If I look up here at this chart, I'm looking at fourth powers. 4 to the 4th power, it's kind of hard to read, but 4 to the 4th power equals 256. So that means the 4th root of 256 would be 4. All right, the next one, I've got a cube root. It's a negative underneath, so that's okay. I'm going to have a negative answer. Remember, 1 is always going to come out as a 1 because the cube root of 1 is 1, the square root of 1 is 1. Underneath, though, the cube root of 8, let's look up here at perfect cubes. I see 8 right there. Its cube root would be 2 because 2 times 2 times 2 equals 8. All right, the 4th root of negative 81. I see that I have a 4th root of 81. It's a 3, but this 81 is negative underneath there. So that would be not a real number because it's a negative to an even root. So just be very, very careful on those so that you don't get caught in ALEKS. Okay, finding the nth root when we have a variable. Okay. When we have a variable, and I don't do a lot of this with the absolute value, when we talk about variables, remember I told you you have a number that's in the index. Okay, that's the number that's in the pocket. If you have a variable underneath there, what we're going to do is we're going to divide the exponent underneath divided by the index. So exponent underneath divided by the index number, and that's how this will come out. So in this case, I've got x to the 6th divided by 3, so that would be x squared. That would be the answer for cube root of x to the 6th. I don't talk about and deal with these absolute values because I just think it's pretty confusing for you. So we're going to practice this rule on the next page. If I have x plus 8 to the 5th power, and then I have a 5 on the outside. Well, 5 divided by 5 is 1. So that means x plus 8 comes out to the 1st power, or you could just write x plus 8. On the next one, I have a negative in front of it, so I'm going to have a negative for an answer. 6 underneath, 6 in the index, 6 divided by 6 is 1. So again, that's going to be x plus 1. You're not going to see a lot of these in ALEKS like this. 4 divided by 4 is 1. So that x squared plus 7 comes out. Incidentally, on this last one, I left it in parentheses because that negative was in front. So that needs to be in parentheses. So I'm just going to leave them in parentheses. All right. The 5th root of 32. If you go back to the chart that was on the previous page, under 5th root for 32, 2 to the 5th power is 32. So the 5th root of a negative 32 would be negative 2. But then I also have a negative in the front of that root. So now I have double negatives, so that would end up being positive 2 for a final answer. For 5x to the 4th, all of that's in parentheses. 4 divides by 4 one time, so that'll come out as a 5x. X plus 8 over 3 to the 58th power divided by, see, if you just divide those, the underneath exponent by the index number, whatever is with that exponent underneath is what comes out. And so that comes out as an x plus 8 over 3. Okay, let's do a little bit of talking about Pythagorean theorem. You may have a couple of problems in Pythagorean theorem in your homework, but Pythagorean theorem is a way to find dimensions of a right triangle, and a right triangle has a right angle in it. That's what makes it a right triangle. So in a right triangle, coming off of the right angle, you have sides that are called legs. The side across from the right angle is called the hypotenuse. So the formula for finding the dimensions for a right triangle is a squared plus b squared equals c squared. Some of you may remember that from geometry, perhaps in high school. So what I could give you is I could give you 2 sides, and I'm asking for the 3rd side. So in this example, they gave us hypotenuse. Hypotenuse is always c. The legs are always a and b. So on this one, b squared plus 9 squared equals 15 squared. And you can see how they worked it out. 81 plus b squared equals 225. They subtracted 81 from both sides. So b squared equals the 144. And then to figure out what b squared is 144. Take the square root of 144, and that gives me 12. So my missing side is 12. We could do one like this one. You've got a store that has a ramp to its front door. The distance from the door to the end of the ramp is 25 feet. So that's down here. The height of the ramp is 7. And so it's asking you to find the hypotenuse, which I'll call it C because we called it C above there. So 7 squared plus 25 squared equals C squared. Well, 7 squared is 49 plus 25 squared is going to be, I believe, 625 equals C squared. So then add your 49 plus your 625, and that's going to give us 674. Probably going to get a decimal on this one. And on the real world problems, you can get a decimal. So the square root of 674, 74 right there, would be, I'll pull out my calculator for this one, square root of 674 is going to be 25.96, it looks like. So that's how long the ramp would be in feet. So that's how you could use Pythagorean theorem. I don't think that I gave you many in the homework, even if I gave you any at all. But just so, you know, if you ever come across dimensions sometime you'll know how to work that one. Okay, be sure to email me with any questions about these beginning roots. We're going to move on to rational exponents in the next section.